And if you read go back, I guess, to the very, very front sheet, which has out all of our topics for the unit. If you're ever concerned, some of you like to plan ahead. That's why we'll go through and give you something that looks like this. But then please understand, when we tell it to you, you can always figure out where our test quizzes are, etc. Pretty much one day at a time. Today is going to be review. We're going to do 31 through 34 today. Next time you have class, you have a, it's not book theory or anything, a quiz on what we're going to go through or what we've covered so far in this unit. There might be a couple other review-ish questions on there, but stuff that you've already gone through and learned before. When we go in to our stuff for today, the first thing up that you'll need, slide over, and I think what page 31 is our very, very first one. We're going to see if we can get this done, and we're going to do 2 of these, and then we'll take a little bit of a break. And it was actually interesting the other day. Which page am I? Right? No, that's where I saw things. That's it? Okay, so this is the right one, right? Is this what you guys are on?
33.
33 at the top, is this right?
Yes.
31, I'm sorry, 31,
31.
Yeah. So if you're on 31 at the top, this is what you're going to go through and see. Your job, when we're going through and doing these proofs, a good strategy in the beginning, look at what you're given. Mark it off and even take it term by term. Say, what is this giving me? What do I know as a result of it? What conclusions can I reach? And so on. Work through all of that. And now this one is not looking for you to get triangles alone. You're not asking to prove triangles congruent. You're asked to prove parts congruent. So we may need to show triangles congruent, but you're not even guaranteed that. Take a look at what's there, read what's there for one, and mark down what we need to. Take what's there, term by term. I go through and look at this. One of those statements to me is way more valuable than the other 3. Which statement gives us, I guess, the most stuff, or I guess is the most beneficial? It gives us a ton, and it's right in the given. Got 1, 2, 3, 4, 5. What do you want to say? If that triangle is isosceles and we know AC is the base, what do you know as a result of that? What conclusions? What's one conclusion that you can go through and read? We'll start at the back and then go forth. So you know that, and what reason do you have for knowing that those big segments are going to be congruent? What would your justification be? How'd you know they were congruent? There you go, isosceles triangle. What else do we know besides just that? Yeah. So which angles are congruent? So you said ABC, so that would be this angle here, and BCA, which is that one there. Now, this came up yesterday, and we were discussing this out. It's a good question to look at. Do you need 3 letters to name either angle A or angle C? Or are we okay with just the one? There's only one angle at A. So make sure, please, we've got that as an understanding. But that one bit, that isosceles piece, let you know that the outsides were congruent, those big triangle sides were, and those base angles were congruent. We also know that D is the midpoint of AB. So if we know D is the midpoint of AB, Aaron, what conclusion can you reach as a result of D being the midpoint of AB? So AD and DB are congruent. Next one up, you know that E is the midpoint of BC. Nick, what do you know as a result of that? So BE and CE are congruent also. We know AF goes through and bisects AC. So I go through BF, which is this one here, bisects AC. What do we know as a result of that bisector happening? Yeah. I'm going to use 3 there. Now, here's our dilemma. We need to show that DF, which I'll give out here in green, that this side is congruent to EF. Now, how could I show that? There's a long process here. You mark down everything. Walk us through. Be as specific as you're comfortable getting. What do you need to show? How can we get there? And how can we get there? So I'm going to trace over the 2 that you just told me. I'll use yellow on them. So you're saying this triangle here and this triangle here. What do you have to do with those 2 triangles? So we're going to show that those 2 triangles are congruent, and we need to show it by side, angle, side. After you show that those 2 triangles are congruent by side, angle, side, what would you need to do next? She's right. That those 2 triangles will be congruent, and we can show it by side, angle, side. All of our labeling shows that. Your job, though, isn't to show congruent triangles. What is your job to show? So how would you know that DF and EF, or those 2 green sides, are congruent? What's that justification? You're right. Remember what it was? 5 letters. What is that short for? Who remembers that? She gave you the letters. It's CP, CTC. What is that short for? Because sometimes, even during your test, don't be surprised if I say you're not allowed to use that as an abbreviation. You have to list out the full justification. You need to know what it is. So if you're getting by with learning a bunch of letters, you don't know what it is. Yeah. So close. There's one word that was off in there. Corresponding parts of congruent triangles are congruent. So we've got to show out that those 2 sides are congruent, and the way that we show out those sides is by CPC, CC, or corresponding parts of congruent triangles are congruent. Understand the proofs that you guys are given. They're going to be a lot. We're going to have steps to show. The good news is, though, I'm pretty loose with what you go through and give out as your reasons. What would we want to say, I guess, to start? Your goal initially is to show side, angle, side. So how would I go through and show out side, angle, side? What do you want to do to start? Perfect. Triangle ABC is isosceles. And I'm going to stop there. We could go back up and reference it, but your reason would be given. And on your state exam, obviously, fill the whole thing in. I just don't want to waste time writing stuff you don't need to. As a result of that triangle being isosceles, what do you now know? There's different steps we can go through and take. What do you know as a result of this being an isosceles triangle? What can we say as a result of that that's going to work us towards showing their congruent? You got an isosceles triangle there, right? What happens as a result of an isosceles triangle? Okay, so did you say that yet? Okay, what else can we say? Okay, so put that in words now. What would you give out for 2? No, you didn't tell me what the congruent sides or the angles were. You said you had congruent sides, right? What are they? What would you put as your statement?
DA and BC.
Not DA and BC.
DA.
BA and BC, yep. So BA is congruent to BC. And you wanted to say something else. You can also throw that in at this step if you want. What else did you want to say? Now, I'm going to give maybe a bigger reason than I normally would. So what justification, finish it off, would you say for making both of those statements? There you go. So you handled now showing that you've got big sides congruent and you've got those angles congruent. What else can I do to work toward? And actually, by the way, we can check something off right now. To show these two triangles are congruent, we said side, angle, side. What can we check off on our list of things to do as of right now? Yeah. The angles. We can't do any sides yet, but we got rid of the congruent angles. Now, you've got to work towards showing one of the sides, sets of sides, is congruent. And we either then are looking at AD and CE or AF and CF. Which one out of those two you want to show would be congruent? Matthew, which one out of those two do you want? Now, if you want to say AD and CE are congruent, that's going to be the one that's a little bit more work. That goes back to the ones that we did yesterday. How would you know that AD and CE are congruent? Good. Wait, our one from yesterday was halves of congruent parts are congruent. Okay? So we need to say first that AB comes from that big line, which we'll go through and say. And then after we say that, the next thing that he walked us through was D and E were midpoints. And then I go into those segments being congruent because midpoints create, or halves of congruent segments are congruent. So first thing I need to say, we need to say that AB is equal to those two small ones together. So AB is equal to, what do we add together? AD and DB. All you're saying is, hey, that big segment can be broken up into smaller ones according to this picture. And then the other one would be what? BC is equal to, yes, we would say CE and EB. And that would just be, when you're adding like that, the addition postulate, meaning if I take the two parts, that equals the whole. So now we've said we've got those segments. We need to now say we've got midpoints. So our reason, you can get these at the same one. D is the midpoint. D is the midpoint of what? AB. And then your other one is E is the midpoint of and the other one was what, BC. And what was your reason there? If we know we've got midpoints, what can we now say? You've listed everything. I said the big segment is made up of two small ones. And now we know we've got a midpoint there. What can we say from here? What do you want to say? Now, you say AD is congruent to which half? You said AD, yes, but what else is it congruent to? Now, she's going to go in to break it up into the midpoint, and if you want to, you can. I actually think, though, that that's an unnecessary step. Let me just go back and double check. So I have this from the state when I did it. And you said You know what we can say right now? I can go in right now, based off our justification. You're not wrong. AD and BD are congruent. I can say something else, though, right now that's going to help me get there. AD is also congruent to what? Yep. What would be your reason? This was the one we learned the other day. Did you say that the big segments were congruent? Yes or no? We said we've got big segments and that they're congruent. And then we said we had midpoints. So what do you know as a result of that? Halves of congruent segments are congruent. Oh, yeah. Now, we went through and showed all that out. What can we say now? So you would next say that bisector, and you said EF is the name of it, is that right? And you said bisects in what segment? And how'd you know that? Sorry, it's so much writing, it's not as much fun. Come up with fun. After you get that step done, so now you said that's a midpoint. What do you know as a result of the midpoint being there? What conclusion can you reach? Taylor, what would you say? And what's your reason? There you go. Segment bisector creates two congruent segments. All right, so we said that. What can we say now? And yes, I know it's a long question. But the good news is you've got 2 steps left and you've done all the heavy lifting. Everything from here is tidying up. Yep. So triangle, and make sure you've got the letters right. You said it's ADF, and ADF would match up to what? CEF, okay. And what's your justification there? Now, what step did you show the first sides congruent? Hands up, please, if you can tell me. What step we showed our first set of sides, or what's one of the sides congruent? What step did we show out sides congruent? Else? Sure, which step? You're talking about those 2 triangles that we just named out. You said it was congruent by side angle side. So when did we show one of the sides between those 2 triangles congruent? What step did that happen at? Not one. One just said it's isosceles. Give me 2 sides that you can identify as congruent in this picture. Yes, but for our triangles. See those yellow highlighted ones? Yep. And where did you show that AD equals CE or is congruent? Which step? 5. Okay. Next one up was the angle. When did I show my angles were congruent? Ben? Two. When did I show the third set of sides was congruent? Jordan? 7. So now you've got those 2 triangles are congruent. And Lucas, what can you now say if you know the 2 triangles overall are congruent? So what would you say? What would be your 9th step and last one? So EF and DF are congruent, and what would your reason be? Nope. What's our reason for that? Hands up, please, when you can tell me. How do we know? You've shown the triangles are congruent. Now you're saying matching parts are congruent. What's your justification? Corresponding parts of congruent triangles are congruent. If you've established the 2 triangles are congruent, now you know all their parts are congruent. Now, yes, because if this happened, how would you get this triangle to match up with this one, they fold over. A goes on top of what? C. So how would you get those? You'd actually reflect it over line BF. Yeah. Okay. Now, what we'll do is this. Take a minute, and what we're going to do is take out your Chromebooks, please. And open up a browser. Go through, please. Get yourself signed in. Make sure you. Actually, do this. You want? Yes. How about open on this? I think I think it'll reach to that. You'll just recognize who you are. Okay. How do I? So we should have 326 total, right? Yes. We're going. We're at 23. Who's not in? Yeah. 1, 2. Okay. Give you another minute.
We're allowed one.
Is it? Or are we waiting for? How many? 26. Okay. So now, are you get with your grouping, please, and get away from the others?
Go back there now.
Remington probably wants to go in the back and try to plug in.
We can stay here. Yeah, I want it. I'm gonna do it. Ouch. Thanks, Alex.
Are we with our groups? All right. Get started.
And each. What are your options? Two angles are congruent and supplementary. No. What about diagonal of quadrilateral lines with each other are perpendicular. Quadrilateral is around there. A diagonal quadrilateral bisect each other and are perpendicular to quadrilateral And you know what? I don't know.
I already did this.
I have no
If you go through now, you know you're changing that up. They're not just proof reasons. Guys, just so you know, these are not just proof reasons. These are things that we should kind of just know by now. There's some stuff on there about seconds. There's some stuff on there about going to and working with naming figures. What's it say? Oh, that's what I just realized. It should be inscribed.
I have definition of congruent.
Yeah, it's not that one, sorry. That one shouldn't be in
What
your
is inscribed angle? I'm not hearing it.
So, inscribed angle is the one on the inside of it. It wouldn't be that. I don't know. You can figure out what you can draw it out. Thank you.
Oh my God. Symmetric property of quality.
You gotta read what's there and talk to your group.
No, you were right the first guess. Makes
All right. Hey, what we'll do is this. I didn't realize there's one question that some of your groupings got that shouldn't be in this set. It should have been in the one for the next unit. But I spoke to a bunch of you that had. When you're going through and doing these, some of you aren't really grasping. I guess it was a little bit odd to see if there's like 3 or 4 of you sitting there. There's legitimately no way for you to answer the question if you're not going to be communicating to each other, like at all. It's striking when you're going through and working. If you don't have the right answer, someone will. So you have to actually find the person who's there. One of the reasons too that we don't go through, and this is just in general, if you go through, you'll see sometimes there's, let's say, drifters who will be like, oh, we'll just sit here for 7 minutes and stare at the wall. Hey, that's fine. Because if that's what we see, understand, is that using the time wisely or not wisely? Not wisely, which means we can't go through and say those, 6 people or whatever it is are going to go through and have their own assessment. What will end up happening next time is I literally have a stack of them over the corner that we can get at any time. If we're not working as a group, we'll just say put them down. You'll have another assessment with 4 questions. We're going to be ready by the end of the day. If it's, you're going to sit there and not get anything out of doing this part. You've got to go through and do the reviews out. You've got to answer those questions and work with each other. Some of you are going to go, this doesn't match any upon. That's right. The correct answer is only going to be on how many people screen? One. And if you don't talk to each other, if you go, I don't have this. First of all, sounds a little irrational. Second of all, you go through and say, I don't have it. Can I see what you guys have? Are you thinking that it's any important? That's how you become a productive member in the group, not sitting there going, no, it's not me. So, do this quick. We'll do one more, but we're going to go through and get one more proof done before we do that. Head back to your regular seat. We'll get you a new one in just a minute. I want to see if I can go in and remove the one question. If I go in right now and read out and start labeling question 6, go over to question number 6, read what's there, please, and start labeling out in question 6. Let's see how much we can get from the givens and so on. As you're doing these out, there are a lot of triangles in this picture. So it's going to be extra important for us as we're listing it out to make sure we're keeping sort of accurate track and naming things correctly. We'll start off with OR being an altitude of MQ. When I list that out, I can label it. What does OR being an altitude of MQ, what does that let you say? What does that give you? How does that work you forward? We got 1, 2, 3, 4. What? Where? Yeah, there'd be a right angle here and a right angle here, so we know both of those are right angles. And if we need it, there's two things that right angles can get us to work towards. Right angles, we could either say are congruent angles, which they are, or what else could you use right angles to go through and show? We did something with this in this unit. Hypotenuse leg congruence. Remember we said you can't do ASS, but you can do an angle side side if it is a right triangle. Meaning you've got to state there's a right triangle and then use hypotenuse leg congruence. That all just came from the first one. So we could either do right triangles, or we could go in and say that you've got congruent angles there. Next one up, it says O is the midpoint. Ellie, what does it let you go through and say if you know O is the midpoint? So far that's correct. That's a secondary one, so you'd have to state the given and then reach that conclusion. What else do I know, I guess, or what else could I say that would help us progress through this proof? In fact, if there's 4 of us, that part is a little concerning. How else could I progress through this group? You're trying to show that that's an isosceles triangle from N to P to R. What do you want to say? You've got a side here that's congruent to itself. How does that help us going forward? We've taken all these steps. This is where you're formulating your proof. how does having all of that help us advance towards our proof? Yeah. We can show, now you said side angle side. What is congruent by side angle side? What two triangles? Give me their names, please. NOR is one of them, and you're saying NOR is congruent to which triangle? And notice the names, everything matches up. So now I've got enough to show those are congruent. What can we say as a result of those two triangles being congruent with that base? We got 1, 2 of us. Yeah. Yeah. We know it will be symmetric. How would you know NR and PR are congruent? What is that short for? Hands up, please, when you can tell me what the CPC-TC is short for. You need to know what that one's going to be. Yeah. Nope. Ross? There you go. Are congruent. Now, once we've stated that those two sides we know are equal, what conclusion can we reach if NR and PR are congruent? What can you say if NR and PR are congruent? What's it? Yeah, that NPR is isosceles. And what's your justification? How did you know? Yeah, isosceles triangles have two congruent sides. So you just listed it all out. Now you're going to put it into words. What do you want to list out as your very first step, Maya? Okay, so I'll go in, start off. Okay. And what? OR. So after we've stated out the given piece, Lily, what can you say next? What do you know as a result of OR being in altitude? I guess well, no, you didn't give me 3 letters, and there's 2 angles at O, so immediately it can't be that. We do know that O is 90 degrees. Any of the angles there, so you'd have to pick a 3-letter angle. But after you state that those are 90 degrees, or I guess you need to say something before that. What would you need to say before that? How did you know that there was a 90-degree angle at either of the angles at O? What's they? We're using pronouns. You got to get words in there. Yeah.
Well, they're perpendicular angles. Perpendicular lines.
Perpendicular lines. And altitudes give perpendicular lines. And what do perpendicular lines give? So we need to say that M, well, I guess you can say it shorter than that. You could say OR is perpendicular right away to MQ. And what would your reasoning be, Johnny? How would you know that those were perpendicular? What do they do? Yeah, altitudes create perpendicular lines. So as a result of those lines being perpendicular, we would go through and say we've got right angles, and I guess I'd say angle NOR. And what was the other one? NOR and POR are right angles. How would you know that those are right angles? What would be your justifications for knowing that those are right angles? Luke? Okay, so we've got that they're right angles. Now what conclusion can you reach that you know they're right angles? Yeah. So NOR is congruent to angle PR, sorry, triangle, angle, POR. And what would be your reason? So now you've handled the angle part. Now let's handle the sides. And Ella, pick one pair of sides on there that we had that we wanted to show congruent. So you wanted to say NR and PR are congruent. How did you know that? Where did we say it's isosceles? Did we get to that point yet? So what sides did you indicate were congruent between those two triangles? Okay, so PO and NO are congruent. How did you know that? So what would you say in your next step? Not yet. What was your reason for that? It's not a wrong statement. You just didn't say why you could say that yet. That door is not open yet. So what do you need to say before you can say those two segments are congruent? How did you know they were congruent? Okay. Did you say O is the midpoint yet? Okay, so that's what you got to say next. So O is the midpoint of, what was it? Okay, so far, and how did you know that, by the way? Perfect. Now, since you stated what that midpoint was, what can you reach from the midpoint? Great. And what would be your reasoning? All right, so we've got those congruent. What's our next set, or what else do we need to show is congruent up there? Lauren?
I mean, like with the OR is OR.
And what would be the reason there? All right, so now we've stated all that. What do you know after stating out all of that information? JD, what can you reach? Yeah. And what was your reason? Okay, so now first set of sides. When did I show them congruent? Brennan? Okay, we got one set in 6. Angles congruent. Marasa, what step did we show the angles were congruent? 4. And then when did we show our next set of sides was congruent? Anthony? Okay. Now, we showed that we've got congruent triangles. What can you say after congruent triangles? Close. Did we say? Oh, how would you know that? How would you know that that's isosceles? Not yet, because what do isosceles triangles have? Okay. Have I shown yet that these sides are congruent yet? No. Have I shown these base angles congruent yet? No. How do you want to show this congruence? It's up to you. You want to do the sides or the angles? You pick. Okay. So, which two sides are congruent? That would make this isosceles. Okay, so PR is congruent to NR. What would be your justification for knowing that those two sides were equal? Remember, you showed the triangles were congruent. If you've got two triangles by the shortcut that are congruent, what do you know about all their parts? So that's how we know those two match up, because they're corresponding parts of congruent triangles are congruent. So now we've stated why those two pieces are congruent. And now what can you say? What's our big triangle? NRP. And what do we know about it? And what would be your reason? So if I wrote they,
Well, isosceles triangles have two congruent sides.
is that all that tough? Not that bad. Now, here's what we'll try. Instead of going and doing more proof, let me get just. Where did we do? Oh, wait a minute. My sets. We'll see if we can get one more game done. Go through, please. Have your pictures. This is just on transformations. So these ones should be quicker than the other ones. Go through, please log in. We'll get you split up in a minute. And it's a quiz, and it's going to be next class. We'll go in and I'll message you out the answer keys to all of those, all 3 pages of it tonight. It might have a couple of review questions, but the vast majority of review. We're waiting. How many we got to hear from still? 2 of us. That's it. So we've got 26. We're still waiting. 22. We're waiting on 3 of us. Still waiting on 3 people. 2. We're getting there. 1. All right. Get with your groups, please. Get up, move around. Find your people.
Dale.
All right, get with each other.
All right, alligator.
Get started.
Oh, we're going to negative. Our minus is positive.
Not yet.
Oh, now I understand. Now this one has to be negative. Negative, negative. That's
That was the rotation of like the y-axis from
It's a Y.
yeah.
How would we? Oh. Some of you guys are getting there.
That'd be 3. That'd be 73 after. Yeah.
That's definitely not.
Oh, we got one winner. All right. Here's what we're going to do. We'll mix it up. We'll go one more round. That went a little bit quicker than the last one. Oh, hang on. Oh, I lost it. Wait a minute. Darn it. All right. Again. Sorry. I hit back. I didn't realize it booted you guys out. I thought it would let me reset what the teams were. Go in. Click your login again. We got 23. We need 2 more. Let's go. We're still waiting. For some reason, it's taking us really long to do something. One more.
Oh, yeah.
All right, get going.
Oh, yeah.
Down -5. It's gonna be down to -9. It's about 270. That's the rotation. I don't know. We'll try and figure out. Like it's at 73.
No, it's 7. It's positive 7.
Wait, it was 73.
Oh, we were getting there. Not bad. Not bad. Get back in your rows, please. We just sent out a remind message that's got the answers to your proofs on it.
That's okay.
No, they're not gonna open.
Do you have a class after this, or can I come in because I don't know what I'm doing, like in one specific thing?
Yep. Just come when stop and give me a minute or two. Okay.
So this.
What do you have after this?
Study,
Study hall.
who's your person for study hall?
Mrs. Simon,